The first half of section 10.5 is the probability of independent events. An independent event, or independent events, are events where one event doesn't affect another. So the outcome of one doesn't change the outcome of the other. And in order to find the probability of both of those happening, all you would have to do is take the probability of one of them happening times the probability of the other, because one doesn't change. And here is an example of that. If we take a survey of students at a football game, and we survey 75 males and 50 females. Of the 75 males, 50 of them are in favor of the team mascot, and of the 50 females, 40 of them are in favor of the team mascot. Now, if I were to randomly select out of the stands one male and one female, what is the probability that both of those people will be in favor of the team mascot? Well, what we're going to have to do is the probability that the male is in favor times the probability that the female is in favor. So the probability that the male is in favor is 50 out of 75, because remember, the probability is the number of favorable over all of the outcomes. The probability that the female will say yes, she's in favor, is 40 out of 50. And so to find the probability that both of them will say, yes, I'm in favor, you just multiply those. And we can actually reduce this down, divide by 5, and you get 8. Divide this one by 5, and you get 15. So 8 out of 15. And I didn't divide that out. You could divide 8 by 15 and get a decimal, or you can leave it as the fraction. Either way, there's your probability that both. Now, the same type of thing if you've got multiple different events. As long as one doesn't affect the other, then all you do is multiply those. And here's an example of that. 46% of parents surveyed read to their kids at least once a week. If I select three parents at random, what is the probability that all three of them will read to their kids at least once per week? Well, we know that the first one we pick, the probability is 46%, so 0.46. Now we pick one more, and it doesn't matter what the other one said, because 46% of all parents, so it's going to be times another 46%. And then we pick the third one, and that one is also 46%. So we just multiply 0.46 times 0.46 times 0.46, and that's approximately 0.097, and you're done. Just multiply it. All right. Now, what happens? Sometimes it's easier to use the complement. We've talked about this before. Sometimes it's actually easier to use the complement than to use the actual event happening. In this case, we've got music on your iPod. You get 16 songs loaded onto that iPod, and they randomly play each day. On your way to school, you randomly listen to about 4 songs. That's the distance you have. So what is the probability that you will hear your favorite song at least once during that 5-day week? Okay, so this one is a little bit trickier, and honestly, I have to stop and think it through. Some of you might even catch on quicker than I do. So you've got 16 songs in all. You're only going to pick 4, but you got 5 different days that you're considering. So in this case, it's actually going to be easier to figure the probability that you won't hear your favorite song, and then find the complement of that, remember, which is 1 minus the probability that you won't. So we're going to say we want the probability that you won't, so we're going to take 1 minus the probability that you will not hear favorite. Okay, so now we have to figure out, oh, this marker is dying. Let's use the other one. Okay, how do we find the probability that you won't hear your favorite song? So what we've got to do, remember, is we need the favorable outcomes out of all the outcomes. Now, so we need some combinations here. The combinations, and sometimes it's easier for me to start with all. So all of the combinations are going to be the combinations of 16 songs taken 4 at a time, because we're going to take, so we've got 16 songs and we're going to take 4 of them, and each day doesn't affect the other, so we're going to take whatever this probability is to the 5th power, okay? So that's where our independent, and now I'm confusing you because that part made sense to me. This part is a little more difficult, so that's why I'm taking longer to get to it. So the number of combinations in all that we've got with these 16 songs taken 4 at a time is the combination 16 taken 4 at a time. And so now we want the number of times that we don't hear our favorite song is there's 15 songs that are not our favorite, and we're going to take 4 of those. Now the reason this is easier is because a bunch of that is going to cancel out. That's why it's easier to do the complement this time than to figure out how many times it will. So, and the reason I'm taking it to the 5th power is that we've got 5 days. So this is the probability on day 1, and then day 2 it's the same probability because it doesn't change. The probability is it doesn't change based on what we heard yesterday. The same songs are still in the mix. So now 1 minus what this is. So now we've got to take, do you remember your how your combinations work? So we're going to have 1 minus, the combination is 15 factorial over 15 minus 4 is 11, is that right? 11 factorial and 4 factorial. And then what I'm going to do is this. This is all over 16 factorial over 16 minus 4 is 12 factorial. And then the 4 factorial times 4 factorial. All right. And then this is all crazy and wild, but watch this. Because this is a compound fraction, you've got this divided by this. So what we're going to do is, and don't forget, this is all to the 5th power. So we're going to take this top fraction times the reciprocal of the bottom one and watch what happens. So 15 factorial over 11 factorial 4 factorial times, flip this one and say 12 factorial times 4 factorial over 16 factorial. So these 4's cancel, and this is 11, this is 12 times 11 factorial, and so the 11 factorials will cancel, and this is 16 times 15 factorial, so the 15 factorials will cancel, which gives me 12 over 16, which will reduce down to 3/4. Ha 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 ha. So all of that craziness. So now we ended up with, so let's put it back together. So we have 1 minus, we said this whole fraction is 3/4. 1 minus 3/4 to the 5th power. And if you take 3/4, so 0.75 to the 5th power, and take 1 minus whatever you get there, you will end up with 0.763 roughly. Okay, so you have about a 76% chance of hearing your favorite song if you listen to 4 each day in a 5-day week. All right. So what we've done is we could have figured out, okay, well this is actually 1 taken to the, okay, but it was easier because of all this canceling out business. It was easier to say, okay, well, it's easier to figure how many times will I not hear it instead of how many times I will. And so sometimes using the complement and taking 1 minus the 3/4 is the probability in one day that you will not hear your favorite song. Okay, so one more. Let's do this type is, what is this called? What are we doing? We have one more problem. Oh yeah, we're going to do conditional probability. One last one. All right, so if I've got this chart, and this chart shows me three different types of cyclones, and the number of times that those cyclones, occurred in the northern hemisphere versus the southern hemisphere. And so what I want to know is first, so step A, number A, I want to know what is the probability that there will be a hurricane. So what is the probability that there will be a hurricane for A? Well, if you'll remember, the probability of anything is the number of favorable over all the possibles. So the number of hurricanes are the 545 plus 215, which is 760. Is that true? Yes. 760 over the total of all of them, and I think I did that already, 1,575. So the number of hurricanes compared to the number of storms total. And this is kind of going back to what we did at the very beginning. It's just using a chart and using, well, let's look at the next one and I'll see what I'll show you what I'm doing. So then that, when you divide it out, 483. So the probability that you'll be in a hurricane in the world is 0.483. Now, so what we've got next is, I want to know, what is the probability that you're going to be in a hurricane in the northern hemisphere, okay? Or what is the probability that there will be a hurricane in the northern hemisphere? Now I want to show you, I hope you can see, this line here indicates a conditional probability. What that says is, we already know you're in the northern hemisphere. If you're in the northern hemisphere, what is the probability that you will be in a hurricane? All right, so this is a given. So we are in the northern hemisphere. What's the probability that you'll be in a hurricane? So in this case, this conditional probability, what we've got to determine is, we are in the northern hemisphere, so we're only dealing with this information. So what is the probability that we'll be in a hurricane? Well, in the northern hemisphere, there are 545 hurricanes over the total number of storms. Do I have that written down? 1,142. So that's the 199 plus 398 plus 545. So we don't even take into account the southern hemisphere, because our conditional probability said we're in the northern hemisphere. I want to know in this realm, what is the probability that we'll have a hurricane, and this you just divide and you end up with 0.477. Easy sneezy. Okay, that's independent. So the independent don't affect each other. So they're actually a bit easier because you can just deal with one thing at a time. All right, see you next time.